Hello and welcome back to part 4 of the Delaware Tech Physics 111 Exam 1 Preparation and Practice Exam covering motion, also known as kinematics. In this section, we're going to go through some graphing problems of position versus time graphs and the information you can get from those graphs. And as you can see in number 1 here, you're asked to actually create your own position versus time graph from a table of data. You see there's a column of position values, these are in meters, and a column of time values in seconds. And anytime you're making any graph of something versus something, the second something is always the x-axis. So time will be the x-axis, position will be plotted on the y-axis. So let's start by looking at our time points. Our time points are from this column of values, and we're going to plot that on the x-axis. So I'm going to label the x-axis time, and that's in seconds. And you'll notice they're evenly spaced, and they start from 0 and go to 10, and that makes our graphing easy. We can just write these 0, 2, 4, 6, 8, 10. And we even have enough space to write 12 seconds in there. Our y-axis will be labeled as position, and that's going to be in meters. Technically, it's in plus or minus meters. And you could put pluses in front of all of your meter position, but it's not particularly necessary for a graph like this that doesn't have any negative values. You'll notice that the position values don't start at 0 and they don't end at 0. 0 isn't even in the list. They range between 33 meters and 18 meters. So you just have to make sure your position values contain that range of data points that you can plot. So you have to have it, the lowest be at least 18 or lower, and the highest point has to be at least 33 or higher. And you'll notice these points are spaced by 3 meters each. 33, 30 meters, that's a 3-meter difference. 27 is another 3-meter difference. They're easily spaced, which means we can write them along the y-axis and label them directly. So I'll just write 18 and 21, 24. And you really want to label it so that your lowest number is on the bottom. You don't want to invert your graph. Makes it harder to interpret. 27, 30, 33, and we have enough room for the 36-meter mark. And now it's a matter of plotting your points. Your first points start with the time 0, and you look for under time 0, there's time 0. You look for the 33-meter position and put a dot there. You look for the 2-meter position, the 2-second position, and look for the 30-meter position to put a dot there. There's your dot for that. Under 4 seconds, you'll notice 4 seconds says 27 meters, so you put a dot there, etc. And you fill in your dots until you have completed. And the last data point is at the 10-second mark, and it is 18 meters. And now you have all your points plotted, and we can, since they do form a straight line, we can create a straight line that goes through there. Do your best to make that line straight. And now you're ready to interpret this information. So the next part of this problem says calculate the slope of the line. Well, you'll notice there's only one line, so it has only one slope. All of those points are on the same line, so it doesn't matter which 2 points you pick to calculate slope. You will get exactly the same slope whether you use the first and the last point, or 2 points in the middle, or any combination of 2 points. So let's keep it easy and use the first point and the last point. That'll make our math simple. And our slope is equal to our change in height in this graph, which is the change in position, divided by the change in width in the graph, which is our change in time. Some people say it's the rise over the run. And in this case, the rise is actually pointing downward, so we expect our change in position to be a negative value. Well, how do we define change in anything? It's always the final version minus the initial version, and that's going to be true for both position and for time. And we fill in the variables. Now it's a matter of finding the right numbers to stick in the equation to get your calculation. Well, the x, f, and tf values are your final point. Well, this is your final point. That's your final point. And here's your initial point. That's the point we start with. So we could label it up here. That's our initial point. This is our final point. Our final position is 18 meters. Technically, it's plus 18 meters. We put that in parentheses. And we're subtracting it from the initial point. Well, the initial point is plus 33 meters. We're going to divide that by the difference in time. Well, the difference in time is much easier to write. It's the final time, which is 10 seconds, minus the initial time, which is 0 seconds. So it's 10 seconds minus 0 seconds. And we get that equation. And now we solve for the top. Plus 18 minus plus 33. Use a calculator if you're not sure about it. This will be a value of minus 15 meters or negative 15 meters. And we're dividing that by the difference in time. Well, the difference in time is just 10 seconds. And if we want to get our final answer, we divide the numbers and we divide the units. And when we divide the numbers, negative 15 divided by positive 10, we get negative 1.5. And our units are meters per second. Well, notice meters per second, plus or minus meters per second, that's the unit of velocity. And in fact, this is the definition of velocity. So the slope of a position versus time curve is the velocity. That's what we've just calculated. And I'll just rewrite what we just did. Our velocity is equal to negative 1.5 meters per second. That's what we just calculated. And you'll see the next part of the question says, what does the slope of the position versus time graph represent? Well, we've determined that since the slope is the change in position, also known as displacement, over the change in time, that literally is the definition of velocity. So the answer is velocity because it is defined as the change in position or displacement over the change in time. That is the same as the slope. And how do we interpret this? Well, we interpret it as saying, since we know our velocity is negative 1.5 meters per second, or our slope of this position plot is that value, it means that the object that's moving is moving to the left. That's what negative velocity means, moving to the left, negative velocity, right? And it's moving to the left at a rate of 1.5 meters every second. That's what meters per second means. So this is how we interpret that information.